Firstly, we're going to look at what is error checking. Now, as I've said to you in my previous videos, computers cannot speak the same language as us. They don't read things in the same way. They just read things as a bunch of ones and zeros. So how do you know that your data, so whether that will be an email, a text message, a document that you've produced on Word, is actually being transmitted in the correct way, the way that we want to see? I'm sure we've all received corrupt files and suffered corruptions before. So how are these errors checked? So during transmission, there's always a chance the data can be corrupted or changed in some way. So it can be corrupted in a way that maybe the file cannot be opened. Maybe there will be a bunch of zeros where your picture should be, or a bunch of symbols. So we need to make sure that that doesn't happen for computers to actually be a reliable source to us. So regardless of the distance of the transmission, so whether this is data is coming from your memory stick or going through a USB cable to the printer, or even being sent from the UK to Australia, we need to make sure that the data should not be changed beyond comprehension. Okay, even though minor changes can happen, we want to make sure that they simply don't. So to avoid this, basically the computers have been programmed to check for a number of errors and correct them where possible. So minor changes that can happen, for example, maybe words can be jumbled up. Here's an example. You would not want to receive your data like this. Okay, not at all. Now, a computer doesn't know that there's something wrong with this. Okay, a computer has no idea unless we tell them. So what happens is there's a minor check that obviously that appears on your computer, and that can be, for example, a spell check. But we're going to look at 4 different types of error checking. So in this video today, we are going to look at parity checking, automatic repeat request, or as known as ARQ. So sometimes it's known as automatic repeat query, checksum, and echo checking. So all of these that we're going to go through in today's video. To begin with, we are going to discuss what is parity checking. Now, this is an agreed method sent by the computers where they will agree to how the data is transmitted, and they use the parity checking to check whether the data has been sent correctly, or if it's corrupt, or if it has been changed. So they need to see if the data has been transmitted and whether it's been changed or corrupted. So this could be over a large distance, or it could be over a short distance, like maybe going from, your computer to the printer and so on. So the byte of data is allocated a parity bit. Now that parity bit will determine whether there's going to be the agreement is going to be odd, or if it's going to be even. And I'll discuss this with you further now. So the parity bits will be allocated prior to the transmission, and as I said, they will be even or they will be odd. So does the data have, for example, an odd amount of number ones or an even amount of number ones? And it's all decided by the parity bit, which is at the beginning right here. So if there's an odd agreement, we are going to need an odd number of ones in. So you can see here that in this byte of data here, you can see there's number 1, 2, 3 and 4. So this would be at the moment odd, but if the computers agree to an odd transmission, then the parity bit here would be a number 1. But if they agree to an even transmission, then a parity bit here will be 0. So here's an example of an even transmission where you can see there's 1, 2, 3, 4 bits. So for example, that is obviously an even parity agreement. And here is an example of an odd parity agreement, because you can see, sorry, I lost my mouse, 1, 2, 3, 4, 5. So the even parity agreed here. So here's the 2 computers, and the 2 computers have agreed to an even parity. So you can see there's 4 number 1s, so hopefully you said, well, what's going to go in there is 0. Then you would be correct. Here is an odd parity agreement. So you can see there is at the moment 4 number 1s in here, so that would be at the moment even. And we would put 1 in there to make it an odd agreement, which is very simple. Now, what if the parity doesn't match? Well, that can be a problem. So if the parity doesn't match, then the data is simply going to be resent, because at the moment we believe it may have been changed or it's corrupted, and it simply cannot be trusted. So therefore it's not sent. Now, although this is a very simple and straightforward method that seems almost fail-safe, the parity agreement isn't exactly perfect, because it's all you're basing it on is a whole bunch of 1s and a whole bunch of 0s, and that can be a problem. So if you're just sitting there thinking, well, okay, if there's a bunch of 1s that, it's odd, then that's fine, it can go through. That one's even, it can go through. As long as it's met with the agreed method, the agreed parity, then the data will go through. So the sender here has sent a pattern of data. There's an odd parity check. So it's got 3 1s, 1 0, 2 1s, then 2 0s. The receiver has received the data, and the data has got 3 1s, 1 0, 1 0, 1 0. Now, that will have gone through, and it would have passed the check because it was an odd parity. However, you can see here the order of the data has been changed, so therefore the data is still likely to be corrupt no matter what. So although parity checking is a very simple, very quick way for the transmissions, it's not perfect. Parity blocks. So parity blocks, these are blocks of data that can be easily comparable. So they're very straightforward, very clever, and you can see here is an odd parity agreement. Now, how you check this is quite simple, and how you can fix the error is really simple as well. So, our columns here have to be odd, okay? And so do the rows. So if I look at the first column here, bit 1, we can see it's 1, 2, 3, 4, 5 1s. Perfect. Okay? It's an odd agreement, so we need the odd numbers. And here you've got 1, 2, 3, 4, 5, 6. 6 is an even number. So we already know quite early on that this agreement is not going to go through. Now the trouble is, we're going to have to check the other columns. Then we've got to check the rows. So like if I check the row here, you can see 1, 2, 3, that's fine. 1, 2, 3, 4, 5, that's fine. So you can see this is going to take a considerable amount of time for us to actually find what the error is. So we're going to need to literally narrow it down to, we know that this column here, this row here, okay, after we have to check the rows, has got a problem. And the same as this column. But the good thing is, we've narrowed it down to this 0 here, and all we've got to do to fix it is change that 0 to a 1 to make our odd parity agreement, which is quite simple, but probably time consuming for the computer, time consuming for the processor. So, automatic repeat requests. This is our next data that we're going to move on to, and this is very straightforward. Our next error checking method, So, it's also known as ARQ, okay, meaning so the Q you got request, but the Q can also stand for query. So sometimes it's known as automatic repeat query. This is a very, very straightforward method check, okay, so error method check. This is very straightforward. So obviously for GCSE you only need to know what it is and to be able to identify it, but for A level we're going to have to go into more detail. But for GCSE, this is what we need to know. So it's a method used to check data that has been transmitted correctly. Of course, that's what we do all the error checks for. We need to know, is this transmitted correctly? Now the sender will send a message, for example, and then the receiver needs to actually send an acknowledgement back to say that the data has been received correctly. So this is known simply as an acknowledgement. If after a certain amount of time the acknowledgement hasn't been received, then a timeout will occur and the data has to be resent. So here's a very simple breakdown. You've got two computers, one's the sender and one is the receiver. The data's sent, it's been received correctly, so an acknowledgement goes back to the sender. So if the data is sent again and basically they don't receive any acknowledgement, then a timeout may occur. So therefore the data will simply be resent. And then an acknowledgement will go back to say that yes, this time I've actually received the data. It's all very straightforward, and that's pretty much all you need to know on that one. So now we're going to move on to our next error check. To what is checksum? So checksum is far more sophisticated than the parity bit, for example, which just checks if there's, as we discussed, an odd number of ones and an odd number of zeros. So what the checksum actually does is that it performs an algorithm to give you exactly the number that you should be looking for. So let's look further into this. So what is checksum? So when the data is sent in blocks, so as we can see with our parity check blocks, we had to go through each column, each row to see exactly where the problem was. Now, if you've got a massive amount of data, you can already see that it's going to be problematic. So what they do here is that the computer does a calculation to see the sum that is sent at the end of the block, which already sounds far more sophisticated and far quicker. So here we are. We've got a block of data, which is just a bunch of ones, which is just a bunch of zeros. So the value to this may be 2 to the power of 8. So 2 to the power of 8 minus 1, for example, is going to be 255. So this will work for blocks of data that are either equal to or less than 255. What is the chances, or what are the chances, I apologise, of blocks of data having a sum of less than 255? Well, obviously quite slim. So I've researched a simple algorithm, and this will check for sums that are going to be greater than 255. So we will start. You divide the sum, okay, so the number is just x, because we don't know the number at the moment. So whatever the number is that has been agreed by the two computers has to be divided by the bytes of 256. Now, you may more than likely get an answer of, say, something like 8.44365, blah, blah, blah. So what you would do is you would round that answer down to the nearest whole number. So that will give you y, so the value of y. So the value of y might be, 8, for example. So what you would then do is you would get the value of y that you've rounded down, multiply that by 256, which will give you the value of z. So then you would get x, which was the sum to begin with, subtract z, and that will give you your checksum. How does that sound? Clear as mud? I don't doubt. So let's have a worked example. Here's your worked example. So x is going to be 2,154. And you're probably thinking, oh, brilliant. But it's very, very easy. So don't worry. It's very straightforward. So 2,154 divided by 256 will give you 8.414065. Oh, great. That sounds like a number that I can work with. Not. So we move on to the second part of our algorithm. So our second part of our algorithm says we need to basically round it down to the nearest whole number to give us the value of y. Okay, so x is 2154. Now we have a value for y. We're rounding that down to 8. Now we need z. So we're going to get y. Y is 8. We're going to multiply that by 256. So that will give us 2048. So now we've got a value for z. So z is 2048. Then you're going to subtract the difference. So do you remember our value of x, which is 2,154? We're going to subtract that from z, which is 2048. So that will give us a checksum of 406. So our checksum is 406. Now you can see that is already a much better and much more sophisticated way of checking our data, because our computer does calculations all the time. Okay, and if it can just simply agree that with the other computer that the value is going to be of x is 2154, therefore it should know the checksum should be 406, because that's the agreement. So I think that is a much, much simpler way of checking, than checking rows and checking columns and, and saying, oh, have you received the data, and waiting for an answer. Then when they don't get that answer, then there's a timeout and they need to send the data again, keep going and going. You can see this is a much, much faster method, much faster. Moving on, there's our last type of check is an echo check. And again, this is a very simple, I would not say this is a sophisticated check at all, okay, but nonetheless, it's useful, it's there, and it does happen. So, our echo check. This is a simple comparison transmission check. So, very simple comparison. So, I think we can already work out now our echo, okay? So you will receive data, you will check that data, does it match with the other data, yes or no? Maybe a data check that you can probably think of is possibly your Google or your Alexa. When you would say Alexa lights on, then Alexa has to, right, okay, is that the data they want? Yes, that matches, I've got that, I can turn the lights on. So the computer has received the data and it will send a copy back to the sender. So if there's an error in the data, then it's got to be sent again. So really simple, okay? It is what it says on the tin. It's an echo check. Now the drawbacks is both sets of data are corrupted. Then there's no way of ever knowing whether this error has ever occurred. And of course, it's a lot of extra data that's transmitted. So, yeah, it's one of the 4 checks. It is there. but I would say it's definitely got its drawbacks, where I think with the check digits so far, that is the most sophisticated way of checking data. It's a very simple mathematical calculation that has a very simple protocol. Right, I hope you found this video informative. So please do subscribe. I am going to be uploading videos weekly. And please do like my videos. Teachers, visit my shop on tests. Resources will be uploaded throughout the year on a regular basis. Some are free and others are very low cost. Don't forget to follow me on Twitter, Miss Price, Computer Science. And of course, I always have a free activity in a description that your teacher may have set you as homework, or maybe you're just doing for the extra study because you're very academic, you're a scholar, you want to get into a great university one day, so you are doing these off your own back. Okay, please do subscribe and keep watching out for my videos. They will be uploaded on a weekly basis.